right. So even if you're still taping or whatever, we're going to go ahead and get started with this. In 2.2, we are going to be identifying functions. That's it. So given a relation, can we identify the function? So if you determining if discrete relations are, last little tab is determining if continuous relations are a function. Open up that first tab. What is a function? Filling in the vocab at the top. A function is a special type of relation where each input, and that word input are our x values. So when we say input, we're talking about the x values, goes to exactly one output. Oh. And when we say output, we mean y value. So each x can have only one y to be a function. So all relations are functions, but not all functions are relations, but not all relations are functions. Okay? Now, why do we care? Because functions are very reliable. And there are families of functions that look and behave in similar ways. So we have like our linear function family and our quadratic function family, our absolute value function family. Those are your function families. In the next tab, we are going to look at functions. So I have given you 4 ways that these relations can be represented and how to determine if they are a function in each way. So when we're looking at ordered pairs, if the same x coordinate occurs in more than one point and the y coordinates are different, then this is not a function. Which means when we are looking at these ordered pairs, really we want to focus on these x values. If this x value repeats, like it does in these 2 points, this is the 0.5, -2, this is the 0.58. What this means is that the x value of 2 has the x value of 5 has 2 different outputs. So this is not a function. And again, it's not a function because x equals 5 has 2 different outputs. So that's why we're concerned at looking at, does the x value repeat? Because if the x value repeats, it means that x goes with more than one y. And we want it to go with exactly 1. You're given one more example of ordered pairs here. And so again, when you're looking at this list of ordered pairs, focus on these x values. Nobody cares about the y. So this is 0, 8, 2, -3. None of those x values are repeated. So this set of ordered pairs, or this relation, is a function. The next representation I've given you an example of is a table. You're looking at the same exact thing. A table is just a set of ordered pairs. So you are looking at these x values, and if you see one more than once, it would mean that that x has 2 different y's. But in this case, none of these x values repeat. Therefore, this table is also a function. Representation number 3 is this mapping diagram. And this mapping diagram, if you are unfamiliar, this first oval, that's the x. And then the second oval is the y. And these arrows are showing you this input value of 0 has an output value of 5. This input value of 1 has an output value of 4. This input value of 2 has how many arrows coming from it? 2, which means that x has 2 y's. So now all of a sudden, it's not a function. And again, it's not a function because x equals 2 has 2 outputs. And last but not least, when you're given a graph and a graph just has these discrete points, if you have points that are directly over another point, that's how you know right away it's not a function. So in this graph, if I'm looking vertically up and down here, I see that these 2 points are on top of each other, meaning this x value of -3 has 2 different outputs, -3, 0, and -3, -4. So this graph is also not a function. And again, it's because x equals -3 has 2 outputs. All right, then our and so with these continuous graphs, I know we are all familiar with the vertical line test. So this heart graph, if I draw a vertical line, I am crossing this heart in 2 different places. So that means that that x value has 2 different y's, which now makes this heart also not a function. And I'm just going to write that it does not pass, and I'm going to abbreviate the vertical line test. So when your graph is continuous like that, you can easily use this vertical line test. The second graph that you're given here is an absolute value graph. And you'll notice that this time, if I draw a vertical line, and if I were to move that vertical line anywhere along this graph, I'm still only going to make contact or come in contact with that graph in one spot. So this absolute value graph is a function. We all remember identifying function, not a function? Beautiful. Okay.